This is Julio Hernandez from HySpex. Welcome to our application lab. Here is where we carry out feasibility studies and explore new uses for our hyperspectral cameras.
My name is Friederike Körting and I'm the Hyperspectral Geology Application Specialist at HySpex. Today we are going to look at our laboratory setup and we're going to look at some drill cores.
We use this basic setup, which consists of some cameras, some lamps, and a moving stage, so that we can scan the objects. In this particular configuration, we have a Veneer 3000 camera and a Sphere 384 camera. Combined, they can cover the spectral region between 400 nanometers to 2500 nanometers. Today, we are going to show you an example of our image acquisition process using some samples from a case that we're currently developing.
Now you can see the data acquisition. The translation stage is now moving the samples line by line underneath the sensor through our illumination and field of view of the camera. For recording new hyperspectral data, we use our own image acquisition software, HySpex Ground. Here we can define the acquisition parameters for each camera, such as the acquisition time, the number of frames, or the acquisition speed, and any other parameters to optimize the imaging process. The settings can be tested before recording, and both during recording and testing, we are also able to use different quality control tools. This can be used to identify if the focus and the signal intensity are adequate, or whether we have pixels in saturation and the integration time should be adjusted. After the image has been acquired, it is ready for processing and the analysis using other software. Here you can see some of the pixel spectra from our drill core. After doing a continuum removal, we are zooming into some of the features in the longer sphere wavelength ranges. Now we're able to see the position and minimum of these features more clearly. A couple of distinct features steal the show: position at different wavelength ranges and with different intensities or feature depth. And finally, this is a minimum wavelength mapping that highlights the different dominant feature positions and depth, and thereby mineralogies.